Welcome to Haltech Elite NSP Training Part 27. In this training tutorial, we're going to learn how to deal with bad injector data when we've programmed injector data from a manufacturer and things aren't working out. So we're super rich or super lean. What do? How do we program things? We're going to break it down here in this tutorial. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at working with bad injector data. What do we do in order to correct a problem on our fuel modeling side within our Haltech Elite using our NSP software? Now, this topic is going to be something you probably run into quite often. Injector manufacturers will supply data, but 9 times out of 10, the data doesn't work, and you're going to find yourself either too rich or too lean at idle and part throttle and wide open throttle conditions because either the injector slope is incorrect or the injector latency or dead time is incorrect, and it's going to cause a problem. Now, just to review this really quickly, because we've spent a few tutorials talking about this topics, we have an underlying airflow and fuel modeling equation that ties together our Haltech Elite of how we actually figure out fueling to our engine. And that's going to be fuel mass is equal to air mass divided by target air fuel. It's a really simple equation, but it's really powerful and underlines everything we need to know in order to properly calibrate, either going after the injector data to fix a problem or going after our VE values within our VE table. So let's break this down. So when we're talking about our air mass, we want to be able to represent and estimate the air mass coming from our VE modeling here correctly. And what we're going to find here is in order to determine the air mass in a speed density volumetric efficiency style calculation, we're going to find that air mass is equal to our map pressure, the reading from our map pressure. It's going to be multiplying that by volume per cylinder. So that's going to be specifying when we enter in the displacement and the number of cylinders, that gives us volume per cylinder. We divide that by universal gas constant of 287, and then we multiply that by charge temperature, which is coming from our intake air temp reading. We can find that right here. And then we take all of that and we multiply it by our volumetric efficiency percentage, the cylinder filling coming from our VE table. So what we're going to find here is we have a couple variables that are going to be hard fixed, meaning we're not going to go in and try to change anything to get the air mass to read differently. So things like map pressure sensor needs to be calibrated, reading accurately. Air temp sensor needs to be calibrated and reading accurately, not getting heat soak where it's artificially over-reporting what that temp's going to be. As long as those are accurately calibrated and reading correctly, and as long as we've entered in the engine displacement and number of cylinders, what we're left with is a variable that we can change to influence what that air mass registration estimation is going to be is the volumetric efficiency percent right here, which is the percentage of cylinder filling. So when we're doing our calibration process, we want to make sure that the VE values that we enter in here are going to be a reasonable value, and that the parameter here, calculated air mass per cylinder, is also going to be reasonable and accurate. This is what we're reporting for the air mass to the Elite, and then from there, it's going to take that value. It's going to take a look at what we're specifying from the target lambda target air fuel table. It takes the air mass and it divides it by the target air fuel, and then we get our fuel mass. Now the fuel mass gets converted from that request of grams of fuel mass into an injector pulse width by knowing what the injector slope or the flow rate is going to be, knowing what the injector dead time or the latency is going to be, and then also knowing what the short pulse width adder, if we have that information available, that will give us a corrected pulse width, or the pulse width that we actually send to the injector to open and close to deliver a certain amount of fuel into the engine. And as a result, if everything is balanced in our equation, it'll allow us to hit the target air fuel that we're requesting. Now the problem is going to be if something's out of whack, if we don't have our air mass represented correctly, let's say we're over or under reporting our air mass because the VE values here in our table aren't correct, we'll find as a result we don't hit that target air fuel. Now if we have reasonable VE values here and the air mass is being calculated correctly and our target air fuel, we're specifying what that's going to be coming from our target air fuel table, under lambda tuning we can see that here. As long as that's all accounted for and everything's correct there, and we're still rich or lean, that means we have a problem on our fuel modeling side of things, meaning somewhere along the lines between the injector slope and the injector dead time latency values, we aren't accurately translating that fuel mass request in grams to an injector pulse width. And that's usually where the error lies. Not always, but usually. So how do we go about correcting this? What can we do in order to fix our fuel model in order to hit the target air fuel so everything's correct? Well, the first thing we need to do is make sure that we have valid VE numbers, numbers in our table here that are going to be reasonably accurate. Now, we still need to do tuning.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.